Greetings. Okay, what you're viewing, hopefully what you're viewing, whilst I wait for the YouTube to try and catch me out. Oh yeah, it nearly caught me out. It's the channel Georges Smith. So let me move my windows out of the way, juggle some windows. Okay, so this is Georges Smith channel. If you'd like to subscribe, that would be cool. Very interesting stuff. And this is Effie Mex. And this is a video that was made in collaboration with George Smith and Effie Mex. So enjoy. I can sit back and smoke and drink tea and see what you think. We will go into this. This is freaking brilliant. And unfortunately for some globelings, this completely demolishes their theory. And unfortunately for some flat earthers, this also completely demolishes their theory. So, but we have to accept reality as it actually presents itself and not pretend like it doesn't. We'll go into this after the video. Okay, so enjoy. The video you're about to see was made by George Kovacevic, whose channel is Georges Smith, and translated by Alexandra Sasha Panich, whose channel is Effie Mex. All I'm doing is giving a voiceover and embellishing on some of the details. This is big, guys. This is big. Welcome to the channel, Georges Smith. Do you know what is the universality of freefall, abbreviated UFF? Well, it's an idea that all bodies, regardless of their mass and their materials, fall at the same speed in a universal gravitational field. This idea is equivalent to the claim that the inertial and gravitational masses are the same, as Newton claimed. Newton's law of gravity can show Galilean's law, and from the equation by which all bodies fall to the ground with an acceleration of 9.81 meters per second squared. It can be clearly seen that the mass of the falling body has no effect on this acceleration, because it's not even included in the equation. Hence, it is also good to mention the material of the falling body. Of course, we are talking about free fall in vacuum. Not only Galileo's and Newton's laws are inseparable from this universality of free fall, so to speak, but Einstein's theory of gravity, the general theory of relativity, is also based on UFF, that free fall universality, which determines that all objects accelerate identically in the external gravitational field. BBC, for example, has many times aired shows in which it popularized this idea.
That is fantastic. And it's a very long way down. Aristotle didn't believe in doing experiments. He believed that logic was enough.
Aristotle, the first true scientist in history. A very interesting statement. Scientists use the scientific method by which to verify a hypothesis through experiments. This is one of the most important parts, and it is precisely the Encyclopedia Britannica who calls Aristotle the first true scientist, despite the fact he did not do experiments. But never mind that. Let's carry on.
I've got here 2 tomatoes, one perhaps 100 grams and one perhaps 10 grams. And he said it was obvious that the big one would fall faster if you drop them together, and what's more, that it would fall 10 times as fast. What's really extraordinary is, first, that everyone seems to have believed him, and second, that no one actually did the experiment until 1590, when Galileo said, hang on a sec, I'm going to test that.
And it is unbelievable. If you ask me, impossible. Think, Aristotle died in 322 BC, so they say. So 322 years went by until the beginning of the new era. And when you add 1,590 years to it, because Galileo did his experiment in the year 1590, you get 1,912 years nobody cared to verify Aristotle's hypothesis. If you believe in this stupidity, you either have a very bad opinion about the intelligence of the entirety of humanity, or you're hypnotized. Newton, for example, whom we already mentioned, was convinced that the time belt is significantly stretched, and that many events from the past occurred much later, closer to our times. I will embellish on this later.
So, according to legend, anyway, he came up here to the top of the Leaning Tower of Pisa.
Did you hear? According to legend, we don't even know for certain what happened 429 years ago, but we know what someone thought 19 centuries ago. Come on.
And he leant over, and I'm going to do exactly the same thing. And he dropped them off. 1, 2, 3, go.
They do land at very slightly different times because of air resistance.
You might notice they said there, because of air resistance. Well, guess what? The air resistance is greater for the larger tomato, which means that it would have been delayed more. But no, the larger tomato is the one that landed first, despite the greater air resistance. But let's continue.
But nothing like 10 times faster. When astronauts went to the moon, where there's no air, they carried out Galileo's experiment with two completely different objects, a feather and a hammer.
Bounce it. And I'll drop some two up here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct.
So if you believe that David Scott traveled to the moon and back in this container made out of cardboard and golden foil, then there's no reason for you to doubt the validity of this hammer and feather experiment. The BBC has also aired this kind of video in which they show how different bodies fall to the ground at the same speed when in a vacuum. So this is another experiment which proves the presence of UFF, the universality of freefall. To be fair, at the end of the video, esteemed Professor Brian Cox imagined what Einstein would say to this. And hence, to say so, cited him.
Reason the bowling ball and feather fall together is because they're not falling. They're standing still.
Svašta čovjek može čuti u današnje vrijeme.
Anything can be heard nowadays. But have you heard of ZAM, Center for Applied Cosmic Technology and Microgravity, and about Bremen's drop tower within it, with a height of 146 meters? I bet you hadn't. Bremen's tower is the main ZAM laboratory and the only lab of this kind in Europe, and possibly the world. For a fee, it opens every day, and for short experiments in high-quality conditions of weightlessness, which can be compared with a millionth of Earth's gravity. So, microgravity, implementing the catapult system developed by ZAM's engineers. The duration of experiments was prolonged to 9.3 seconds, which is unprecedented worldwide. And all this in a vacuum. In this same tower, Dr. Gyula Sas made an experiment on June 21st, 2004, and the BBC didn't report it. Dr. Gyula Sas put into a capsule 7 cylinders of same mass, which means same weight, made from different materials. Everything was carefully packed into the ZAM capsule and carried to the tower. Then the air was taken out of the chamber and the capsule was catapulted in vacuum. In this weightless state condition, a camera recorded everything by making 25 photographs per second. But you have not heard of this experiment or seen anything about it. It is not taught at school. And here is the result of this experiment recorded by the camera. You notice on the right the lead. You notice the drastically different volumes, but regardless, they're not exactly falling at the same rate as, say, the carbon or the iron or the lithium or the barium. No, looks like it's not very universal, this universal. As you can see, the cylinders didn't fall at the same moment, at the same rate. In other words, UFF, the universality of freefall, was not present. Shocked by learning this, I decided to contact Dr. Zaz. I wrote to him. Greetings from Serbia. If I understand this experiment correctly, it shows that Galileo's experiment is just a legend. And it is not true that all bodies in vacuum fall to the ground with the same acceleration. Does this mean that gravity is not directly related to the mass? And that there is something else that determines the acceleration of the falling bodies? To my great satisfaction, Dr. Zaz responded, yes, the acceleration of bodies are related to the product of the gravitational charges of the bodies, and not the product of the mass of the bodies. If now you ask yourself, what with the Newton's law of gravity, which states that all bodies are mutually attracted by forces which are proportional to their multiplied masses, and inversely proportional to the squared distance between them? Well, that's a good question. As you can notice, Dr. Zaz even titled his email with UFF is not present in the green box, top left. And on his YouTube channel, the video which shows the experiment was titled, Einstein is wrong. Also, Dr. Zaz points out that, like every other experiment, this one should also be repeated in order to eliminate any errors and to verify the results, also known as peer review. Why hasn't this experiment been repeated in the past 15 years? Listen carefully. The Bremen Towers management does not allow for this experiment to be repeated. Think about it. Thanks for your time.
And thanks to George Smith or Georgia Kovacevic. Okay, that was pretty cool. Now, please go to their channels. I showed right at the beginning what their channels are. Go to their channels and give them a thumbs up because they found it. This was George's find. It was George's work. Now, we're going to go a little bit further into it, okay? This is a website. Let me just highlight this so I don't lose track of where I am. Okay. This website was made by Mr. Zaz, the guy that did the experiment. This is his website. In this website, he explains, okay? So, yeah, tell you what, I will paste the link in the description, in the chat right now, and people can take a look for themselves. Just give me a second. Some of you might have already read it, but some of you will not. And this isn't going to be just serious stuff. I am going to cover serious stuff in a different way shortly, but give me a second. Right, where am I? Here. Right, here comes in the chat a link to the website that I'm about to read from. You can check this for yourselves, okay? Especially you, Globelings. Marie, nice to meet you. I remember you. You have a wrench as well, like everybody else. Globelings and flat earthers alike. Okay, so here he describes the experiment and why he did it. He has a different theory, and his theory is correct. Okay, so I'm going to read where, never mind, it stopped being highlighted. I'm going to start reading from here, okay? So let me make it larger so people can read it to a sat on their sofas. 2003, with my conception of drop experiments, I tried to get a launch in the drop tower of ZARM in Bremen from the gravitational physicists without success. My further efforts were crowned with success by the DLR who supported my drop experiment at ZARM. In other words, some corporation, some larger organization said, we'll grease the pads for you. We'll open some doors for you. So these guys said to the ZARM guys, hey, you've got this tower, don't now, you're doing this experiment. So they did the experiment. Now, here's letters and whatnot from the DLR people to the ZERM guys to say, dude, what the hell? You've got to let this guy, this is a real physicist, have him do the experiment, bitches. Now, 2004, on June 21st, the drop experiment was performed with lithium. Sorry, I jotted it down because I didn't commit the periodic table to memory, believe it or not. So lithium, beryllium, boron, carbon, aluminium, iron, and lead. Okay, I did know some of them, but I didn't know this one. I forgot BE. Anyway, as test bodies in the drop capsule consisting mainly of aluminium. That's the capsule consisted mainly of aluminium. Okay, not that these were blended or alloyed into aluminium. Okay, just globulins, just these were pure in the capsule. Okay, so the drop experiment was performed with these as test bodies in the drop capsule consisting mainly of aluminium. The drop capsule fell in vacuum, but in the capsule was normal air pressure. Okay, that's a closed system. You know, your train and your plane that you use in your models when you try to say relativity. Okay, well, that's a closed system. There's normal air pressure inside the capsule, but the capsule itself in a vacuum chamber, a vertical drop chamber. The GLP protocol shows that DLR confirmed that they were present during the drop experiment. The technical staff from ZARM rejected to sign the protocol. The video shows the results during the 4.7 seconds drop time. Okay, we've seen the video and you can see it to your heart's content. Now, 2 days. Now, why have you not heard about this? Why has this not been in Popular Mechanics, the New Scientist? Why is this not known? Well, this is why. 2 days after the experiments, the gravitational physicists of the University Bremen started a worldwide email action to the reviewers of physical journals, that's journals of physics, not to publish the results of my drop experiment because, and here comes an ad hoc explanation of the abhorrent behavior of those falling bodies, which should have all fallen at the same rate, but didn't. In the experiment of Dr. Zars, movements of the test bodies are due to unspecified initial velocities. Wait a second. All of it rose at the same rate, all in the same chamber. Can't be unspecified initial velocities. It's not like some of them were housed in a little container of highly tensile rubber and others in very soft sponge, and that somehow had an impact where some received some initial velocities whilst others did not. Okay, this is called an ad hoc explanation. There's no... Anyway, let me continue. Due to unspecified initial velocities induced by transient disturbances, so disturbances that are not constant, that's what transient means, which came in through relaxing the internal stress of the capsule. So there was some internal stress of the capsule that was relaxed, probably by the inertia of the bottom of the capsule being pushed up, whilst the top, well, some contraction must have happened and this must have relaxed something somewhere, and this went on to cause this unspecified initial velocity. Right. No violation of the universality of freefall can be inferred from that experiment, which does not meet the most basic scientific standards. It was done in our scientific laboratory with the help of our technicians, but it does not in any way meet the most basic scientific standards. We believe that a publication of these results will be detrimental for gravitational physics and gravitational physicists. And I'm one of those, and I want to carry on paying my mortgage. The scientists who wrote these lines were neither involved in the measurements, nor have they had insight into registered experimental data. They did not have permits to evaluate the video. The question remains why publications of investigations about why research about, I think this might have been my research about basic principles of physics are not accepted, and why a suitable verification of the oldest hypothesis of physics, the UFF, cannot be performed and published. Is the equivalence of inertial and gravitational mass really confirmed? No, it isn't. It really isn't. His video shows it. The rejection of all my investigations since 2002 forced me to write this book. So this website is a link to his book where he explains the ins and outs of everything. The guys who work at the place where he did the test, proving their theory false, ought not to have said, don't you go around publishing this. What you should do instead of publishing this, well, wait, was I showing that page? Yes, good. What you should do instead of publishing this is, I know, like, you might think that what we should do is, like, maybe do it ourselves, repeat it, maybe we should repeat it. Maybe repeat it several times with different variables, maybe. But maybe it's better if you just don't publish it and we don't repeat it. How's that? Is that agreeable with you, sirs? That's what happened. That's why people haven't heard about this. It's been 15 years, folks, and that place is still open. It's not like they decommissioned it, but I bring you something else, okay? I'm going to close that so I don't lose my thread of where I am and what's going on. What's this? Oh, yeah, I'll go into this. It's good. Now I will stop sharing this. Where am I? Here. Yes. Okay. There's something else that hasn't been covered by that. So let me stop screen sharing. And it's very simple. And I haven't done the math because it's beyond me. Oh, no. How can you accept that something's beyond you? Well, because some things are beyond people, isn't it? But here's the thing. Sometimes you'll have a mathematician who knows complex formulas for resolving certain mathematical questions, but they won't have the inventiveness to troubleshoot and conceive of the problems. They might be able to solve the problems once they're presented to them, but not to perceive or conceive of the problems. Like this, okay? Take a screenshot. Take your time. Let me make sure there's not too much reflection. Okay, got it? Good. Now, this is the Globling's closed system, like a train where you drop something, you throw it up and it comes down and it's all traveling at the same velocity. Pay attention, Globlings. The circumference where Bremen is, you can find that with Google Earth, okay? The circumference means that the feet per second or the meters per second can be worked out. That's kind of easy, okay? When you work out how much the surface of the spherical Earth has moved in 4.5 seconds, it turns out to be 77 centimeters. According to this closed system, the object would go up and move across 77 centimeters to land. Here's the catapult, and here's the box that they receive the capsule in. Okay? Perfectly fine. This all moves 77, this all moves 77 in a nice flat straight line. But the globe Earth is not a flat straight line. It's a sphere, which means that the 77 centimeters of the surface is smaller than the 77 centimeters at the top of the tower. So it must have accelerated. This is one of the points that Brian Mullen used to make. It must have accelerated to its zenith and then decelerated to land back at the base, which means both an increase of velocity and then a decrease of velocity. That sounds like a wizard did it, doesn't it? Like, it goes up here. This is a longer line. See, this is Earth's radius. Okay, so we understand. Okay, that's Earth's radius. See, this line is smaller than this line. See, This is a longer line, but the thing has to go up and fall down at the same point. See, Coriolis and all of that. But it seems like none of this was going on. It seems like either this was going on, so the Earth was moving in a straight line. Oh, sorry, just got a notification from the Hangout people. What do you want? Clear off. Right. Either Earth is flat and moving in a totally straight line, not a large curve, okay? Or it's flat and it's not moving, folks. Now, Krauts, go ahead and do the math. Figure it, work it out. Work it out with the ratio, with 100 feet, 109 feet, I think it's the maximum height that the capsule goes to. Work out the ratios, the difference in terms of distance, like surface, the distance at the sun, okay, 77 centimeters, and the distance at the top. And notice that it didn't get towards one side of the tower or the other at any point. It's almost like it went up a completely static tower, went up a static tower and fell down a static tower. Not a tower that was doing this. Can you see what I'm doing with my fingers? Where this is moving 77 centimeters and this is moving more than 77 centimeters. Okay, Krauts, please do the math and pass it to me. I'll share it. I will share it. So, in one fell swoop, the guy has demonstrated, well, actually, universal free fall, it's not true. It's not true. At least not, no, I mean, it's just generally not true. They don't all fall at the same velocity. It's not true. They all fall, but not at the same velocity. Okay, so let's stop it with that universal free fall malarkey. And with that, I'm going to screen share again to Globebusters, who I'm sure will not issue a copyright strike. What is this notification? Oh, Hangouts. This is a notification. Hangouts on Air is going away later this year. Oh, Hangouts on Air are going away later this year. No more Hangouts. No more of these. YouTube is like, we can't handle it. We don't have enough people to monitor everything. The bots can't do it properly. So anyway, there you go, folks. You heard it. You heard it here if you hadn't already. So what I'm going to do is I'm going to screen share and we're going to discuss on the back of this, which, by the way, supports what Bob Nodell was saying. That's right. That's what it supports. So let me start screen sharing. Or at least it goes a lot and much. It goes to support what Bob Nodell was saying a lot more than what Iru Landucci or Geronism were saying. So please listen. And I am pretty sure that I will not get, oh, look, see this person, Nora no one. This is an agent. This person, this with a wrench is an agent. That's right. An American agent who lives in Ireland, who's an artist that's shit. So can't be like paying their rent from being an artist because they're no good. And just lives in Ireland. You know, like if the American government wanted to keep tracks on, like, I don't know, the IRA or any of that stuff, just have somebody who lives there because that's how things go. Anyway, forget that. We're going to play a portion of this. First, Bob is going to ask Jeron to explain why things fall. So please listen.
So now what I want you guys to do is I want you to participate in a thought experiment. But before we do that, Jeron, I want you to explain to me why precisely you think that density or relative density is all that is required and that no force is needed whatsoever to make the world go around, so to speak. So if you
I think I already have. I don't think I need to bring up definitions of words. I don't think I need to bring up
no, you don't. I just want to know your general take on it. You know, nothing, you know, I just want to know. I'm not even going to try and fight with you about it. I just want to hear what you have to say.
I think I already described it. I don't know why we'd have to go over it again. I told you that if we consider the density of air as the number one, that
now remember that the video we just watched from Zam, thanks to George Smith, said actually density isn't this thing that you can just claim. is a get out, because it isn't, you know. But let's carry on.
Everything that has a density greater than that 1 is going to fall down in that medium, and everything that has a lesser density than 1 is going to rise in that medium. Now, again, if John wants to come and say, well, why did things go down? There has to be a preferential direction of down. Well, there doesn't, because no matter what items in disequilibrium, no matter which direction they went, and they have to go in a direction, that
No matter which direction they went. If somebody says, look, why did the leprechaun jump in that pond? If you say, it makes no difference why the fairy was baking a cake, that's called a non sequitur. It has no bearing on the matter. Nobody has said, why do things fall sideways? Or why do things fall up? Bob has just asked, why do things fall? So asking why things fall sideways, nobody has asked about things falling sideways. That's been brought in only by Jeranism.
the direction that we would call down. That's the direction that earth and rocks and grass and weeds and everything would be, and that's the direction that the oceans would be and the lakes, and that's the place our feet would be. So no matter where it went, we would be calling it down. So to say what?
Yes. Well, there's an overall agreement in reality in the English-speaking world that things fall, when they fall down. And when they rise, they rise up. That's integral to the meaning of the word fall, is that it falls down, and rise, that it rises up. That's part of the meaning of the word. It's like the word table is an agreement that we will call that flat-topped thing, we'll call that a table. It doesn't matter that that you could call it a chair. It isn't a chair, it's a table, because we call it a table. But we call it a table so that we can all agree that that's what table is. If somebody says, but I think it's chair, it's like, well, you're wrong. It's a table. It's like, okay, well, what if down was up? It's like, well, it isn't. A table is not a chair. You understand? Table is not a chair. A chair might have a flat surface too. Might have qualities that are similar. Doesn't mean that it is, okay? Now, what Jeremy is doing, instead of answering the question of why, what would compel it to fall, which is what Bob has asked, he's saying all kinds of stuff that have nothing to do with explaining what mechanisms might be kicking in that cause something to fall. He could have said, I don't know, maybe there's some electrical static force that we don't understand yet, and we've been looking at it and studying it and thinking it's gravity, this thing that forms planets, that's what it is. Instead of going, well, it's not gravity because this guy in Canada, Hutchison, has been taking heavy things and making them like float without changing the density of anything, really. He's just been using like electric fields. So maybe it's an electric field thing. He could have said that, but he didn't. Instead, he said all kinds of things, non sequiturs. So let's continue a little bit.
Things go up is, to me, an absolute ridiculous statement. I mean,
So nobody said, why don't things fall up, other than Jeranism? And that's called a straw man argument, when you bring an argument that hasn't been made and you then demolish it.
How could you say that? No matter where we were existing, no matter where it was, we would call where our feet were down. So the fact that you can take a golf ball and put it in the air, it's in disequilibrium.
No, it isn't. Now Jeranism's going to say the golf ball in the air is in disequilibrium. No, please look up the meaning of equilibrium. Equilibrium is the golf ball's coherency as a golf ball. Is it more golf ball when it's on the ground and therefore has all its equilibrium? No. The golf ball is a golf ball. It's not in disequilibrium. It's going to fall if you let go of it, and it's going to rise if you let go of it and you're underwater. But that has nothing to do with the ball's equilibrium. Nothing at all. But let's continue.
Disequilibrium. That golf ball has to go somewhere. And
why does it have to go somewhere? That's what Bob has asked. Please explain why it goes somewhere. Jaron thinks if it all went sideways, reorient the whole world, and everything would be sideways, and we would call that sideways down, and the golf ball would fall, well, in the newly defined down, formerly sideways. Okay, why? So there's no explanation there, but let's continue.
Like Ebru said, there's an order to the universe. So trying to
Why? Why is there an order to the universe? You can look at the question that Bob was asking was kind of simple, and that's the kind of question that drives scientists to truth. Like, do they really fall at the same rate? Answer, no. All of the things that said it fell at the same rate, or any theories contingent on that being a fact, are wrong. That's why it's theories. So it is not a fact that they fall at the same rate. So the theories that are contingent on them being facts have to be scrapped. There might be salvageable elements, and here comes a magnetic field that explains it. Oh, there you go. That explains it better. That's what science is about. But let's continue.
Why it goes in that direction is just ridiculous to me. It has to go somewhere, and whatever direction that went would be where.
This has to go somewhere. It's like leapfrogging the question. Why does it fall? Because it has to. It's like, okay, but why? Well, it just does. Oh, okay.
The Earth would be where the most dense items would be, like the oceans, like rocks, like basalt, like concrete, like everything that there is that's more dense than the air it's in would go in that direction. That would become down. So relative density and just what I just explained, without having to go through little definitions, without having to say, well, this is what force equals, and this is what acceleration equals, and this is what Newton said, and this is what Einstein came and said. I don't need any of that. And I think the universe is much more simple than that. I
don't need any of that. The universe is a lot more simple than that.
To follow the directions left for me by these guys saying, well, this
don't need the directions. I'm going to play that last little part. Don't need to know any of those things. Don't need to follow any of those things. Listen.
The oceans, like rocks, like basalt, like concrete, like everything that there is that's more dense than the air it's in would go in that direction. That would become down. So relative density and just what I just explained, without having to go through little definitions, without having to say, well, this is what force equals, and this is what acceleration equals, and this is what Newton said, and this is what Einstein came and said. I don't need any of that. And I think the universe.
Now, yes, Einstein said a bunch of stuff that's a crock of nonsense. Lots of things that have been said by scientists, or so-called scientists, is a crock of nonsense. But some of the things that they've said are correct and true. If you want to see whether there's any veracity to what I just said, look at the military and let's see if they're working with stuff that's just nonsense, or let's see if they're working with stuff that's true. Like they have to know how far is this shell of this weight with this amount of explosion, of explosive or propulsion, how far is this going to go? So that they can, use it. There's no use trying to hit a target 10 miles away with a missile that's only going to reach 5 miles. They have to know things like that. I mean, it'd be better if they didn't do it, but they do. And they do know things. But generally saying he doesn't need any of that.
Much more simple than that. I don't need to follow the directions
Don't need to follow the directions. Now, just so people don't say that I'm just cherry picking.
Or left for me by these guys saying, well, this is what a force is, and it has to equal this, and acceleration can only happen because of a force, and everything has inertia. To me, I don't need any of that.
Don't need any of that, okay? Just so that you know, I'm not just cherry picking. Hey guys, delivery drivers, all you guys whose cargo is fish, just grab your keys, get in your vehicles, press pedals and do things, whatever you need to do. We're not going to give you any directions, just press things and go and deliver the stuff. Where should we deliver it? We're not giving you any directions, just go. That's what Jeremy's saying. Don't need directions, no, in the world, you don't really need directions and stuff from people that figure stuff out. Don't need any of it. It's stupid, Jeremy, it's silly. It's really silly, dude. So, I'm going to play a little portion. I might get a copyright strike. This is from the film Idiocracy, and I give kudos to Orphan Red, who came to visit me, by the way. That's right. She's lovely. Now, it was her idea to show this this a video clip, which I'm going to show now, and which I'm watching my Hangout screen in case Google decides to like interrupt the transmission and say, oh, you're not showing this. Just so that you know, Google guys, I'm actually mocking flat earthers right now. Okay, so you might want to hold your finger off the button. Okay, so this is a guy who's right now playing the role of Bob Nodell, arguing with people who are playing the role of Irulanducci and Jeranism. Okay, enjoy. Oh wait, preamble. He's just learned that they're not making enough food. The crops are failing. The crops are failing because they're not irrigating them with water. They're irrigating them with like Gatorade type drink, sports type drink with electrolytes. Okay, so listen, and then go and watch the Globebusters again, and you'll see it in a context that better fits.
For the last time, I'm pretty sure what's killing the crops is this Brondo stuff.
The Brondo's got what plants crave. It's got electrolytes.
So wait a minute. What you're saying is that you want us to put water on the crops.
Yes.
Water. Like out the toilet?
Well, I mean, it doesn't have to be out of the toilet, but yeah, that's the idea.
But Brondo's got what plants crave.
It's got electrolytes.
Okay, look. The plants aren't growing. So I'm pretty sure that the Brondo's not working. Now, I'm no botanist, but I do know that if you put water on plants, they grow.
Oh, well, I've never seen no plants grow out of no toilet.
Hey, that's good. You sure you ain't the smartest guy in the world?
Yeah. Okay, look, you want to solve this problem. I want to get my pardon, so why don't we just try it, okay? And not worry about what plants crave.
Brondo's got what plants crave.
Yeah, it's got electrolytes. What are electrolytes? Do you even know?
It's what they use to make Brondo.
Yeah, but why do they use them to make Brondo?
Because Brondo's got electrolytes.
Okay. Eventually, the guy in the white shirt, in the white top, because he's not getting through to them with like logic and reason, instead persuades them that he can speak to plants and hear them speaking back, and tells them that the plants have told him that they want water, and that's what it works. Haha. So I just got the notification from YouTube. Thank you. That's enough. It's got electrolytes. It's the equivalent to flat earthers saying relative density. Like, you're stupid. This relative density comes, wait for it, from the Flat Earth Society, where the sun making circles over the AE map comes from. That same place. That's where the relative density ultimately comes from. Now, I'm not going to go on much further about the Globebusters thing, but Bob goes on to say, not say, but demonstrate irrefutably with empirical evidence that that's a crock of nonsense. And I'm going to try and find it. He shows a plane, the 0G plane. Where is it? Have I shown it already? No, wait. I don't know. I might not be able to find it. Ah, yeah, there it is. Right. So here you have liquids that are separated according to, well, relative density. The blue liquid has more density than the kind of yellowish liquid, which has more density than the clear liquid, which yeah, okay. That thing that flat earthers say, who don't do much thinking, but do certainly do much repeating, okay, the stupid flat earthers, and there are some very stupid flat earthers out there. You know, I mean, let's face it, we've had flat earthers who say that there's an eclipse of the sun every single month, but like people just don't see it, okay? Even though they last like 5.5 hours, doesn't matter. People still don't see them. Now, this is in the Vomit Comet. When there's no longer a downward acceleration, they don't retain their relative densities. it's very peculiar. It's like the only thing that's giving them this stratification is not the actual density, but the density combined with a downward accelerating somethingness, which could be an electric field of some type that has been misunderstood as gravity. And when the plane, I'm going to play it but without audio, when the plane goes into the 0G, into the apex of its flight, to the top, these, they blend, they stop being stratified. Watch. There you go. They've gone into free fall. Now they're in free fall. He didn't shake it around. You notice, I'm going to play that again, because one of the objections was that he shook it around. It's like, look, first, he doesn't shake it around. He's trying to hold it pretty still because he's got a camera there, but he's kind of starting to float. But he manages to keep it relatively centered in the frame, okay? He doesn't shake it around to mix them up. Watch. He's talking and suddenly he's like, oh, we're going to start, oh, and watch what happens. Here you go. They're starting floating. Oh. It's almost like he's giving it a very vigorous shake, but he hasn't. They just stopped having their coherent densities. And they repeat this several times where he does give it a shake. And Jerry Nissim said, oh, it's all because he's giving it a shake. It's like, no, it's because they don't have the thing that gives them their supposed coherent density, their relative density. It stops being, well, their relative density. See how now he's mixing it up? And they go back to the point where they're no longer floating. And instead of separating rather quickly, like happens in the real world, don't believe me? Get a glass of water, put some oil, mix it all up, and see how long it stays mixed up. Not very long, like seconds. But no, there you go. Okay. So see the standing? It hasn't separated. It didn't separate, did it? No. It's like the relative density thing. It's just another thing that people have been repeating without actually thinking about sufficiently to test. And when we know that when you test things, it's like, oh, turns out that a lot of our fundamental beliefs were simply beliefs that we didn't test because we were so convinced that they were correct. They're not correct, but the only way to know that is to actually test them. So you think that instead of repeating stuff, flat earthers, of all people, would go and test stuff. But no, they're still repeating, and it's stupid. It's stupid to carry on repeating stuff. Let me stop screen sharing. To carry on repeating stuff when you know that you've been programmed to accept stuff and not check it. Well, okay. Well, then how about we check everything? Let's just start checking everything instead of just repeating, so that you don't look like a dim-dim. So that's mainly that. Let me see. Let me close this. And yes, close that. Where's the other thing? I have something else hovering. Yes, here. Okay, now I can see what's going out in the stream. Five Door says, hi all. Antonio, could you go through how to get yes, I will. How to get the 77 centimeters number, please. Cheers. I will. I'll do it right now and I'll do it live. Give me a second. And remember, the 77 centimeters are theoretical based on the Earth being a sphere and rotating. Okay, it's theoretical. If the Earth was a sphere and not rotating, there would be no 77 centimeters. So, but that's not the model by which most people live, is it? The globelings, they don't live on a spherical but non-rotating Earth. No, they live on a spherical, rotating Earth. Okay, well then let's check. And it's like, oh, no, when you check, it turns out, oh, it isn't. it's not rotating, that's for sure. And then when you check again with like the curvature calculations, it's like, and it's also not curved. Oh, okay. So it's not rotating and it's not curved. Is that right? Yes, that's right. Okay, what is it then? The only other thing that it could be flat. It can't be concave, because if it was concave, well, it would show in the like observations. It would show, and it doesn't. Right, so let me screen share. I'm going to have to share the whole screen. I'll show you how to do it, okay? 5 doors, I think it was asking. So give me a second. Right, no. This is what I want to share. Here you go. Right. Right, here you have Google Earth, and here you have the tool, measurement tool. What you do is you go here and you write Bremen, which is where that university is, with the with a drop tower. Okay, so I've done Bremen. It's about here, and we're waiting for Google Earth to find it. Take your time. There you go, right where the pin is, just about, well, my cursor. There you go. How's that for spot on? Okay, so that's where it is, okay? Now, oops, I'm going to go farther away so that we can see the north, okay? And I'm going to let go of that instead, so clear. I'm going to go to circle, okay? The pin is going to remain there. So you go to circle and you come to the north, okay? Can be as precise as you want. It, by the way, don't know if you remember when I went all the way into the north, where it becomes a kind of a Twilight Zone dimension door or something. Yeah, on Google Earth. Check it yourselves, Globelinks. Right, so I've dropped that in the center, and this will be the radius. Let me, there you go, go here, okay? If you want, you can find the coordinates for the actual Bremen Tower. Now, this tells us that this circumference, okay, so I'm going to, no, I'm not going to save it because then the numbers disappear. Okay, see that, this yellow circle? That would be the circumference of the latitude where Bremen is. And the Earth rotates around this axis and the south axis. Supposedly, that's the theory. Well, the circumference of this area, this latitude, is of, let me see, 15,004 miles. Here you are, you have it there, okay? You divide that by 24, then by, so you divide that by 24, then divide that by 60, then divide that by 60, and you have how much it moves per second. You know how long it's falling for, because it's falling for half the amount of time. The whole thing is just over 9.5 seconds. So half of that is how long it's falling for. It goes up, tiny lull, then down. And this is just on the falling, the 77. I think I worked it out on just the falling. I forget now because I did it a while ago. But that's how you work it out. Here you have the distance. You divide that by 24, which is how much it would move per hour. You divide that by 60, which is how much it would move per minute. You divide that again by 60, and you have how much it would move per second. There you go. Anyway, so that's it. You're welcome. Now let me stop screen sharing without showing the link. So folks, I suggest you download this, because it will sooner or later disappear. Download the previous video with this Zam, where he urged them to repeat it, but instead they decided, tell you what, instead of repeating it, we're going to prohibit its repetition. That's what we'll do. How's that? Never mind, repeat it and remove any factors that could be considered as contributing to this abhorrent behavior. Oh, what I'm going to do is I'm going to show it again, but in slow, no, not in slow motion. I'm going to show it again over and over. And you'll see Like, that's interesting. Lead falls slower than carbon. That's very interesting. I mean, lead is kind of a bit heavier than carbon. But no, never mind. Right, so let me see. Just give me a second while I find what I'm looking for. Einstein is wrong. That's what it's called. I see people without saludos Antonio desde Sao Paulo. Saludos Olga Díaz. You're going to have a range too. Stephen Allenbow, climb down from your high horse. Not everybody's an enemy. Anyway, so right, I'm trying to show this, but YouTube keeps playing funny with me. Per second, 5 doors. 1 second. Where am I? Yes. Okay, I can close this, which is just using up resources. By the way, if anybody wants some comic relief, watch the TV series Barry. It's funny. And I don't get paid by HBO, who make Barry. I don't even have HBO. Right, anyway, never mind all that. Daniel Smith, almost is nope. I'll play it again. Daniel Smith writes, and I bet lithium also falls faster than lead. No, nope. It's right. Wait a second. Come on. At the top of the video, you have the what each element is. So give me a second. So not to side with Bob Nodell, because for anything other than he's kind of right in what he's saying. Right, so here's the video. I have it. I'm going to screen share. On the left, we have lithium. On the right, we have lead. Oh, here we are. Now, the Globelinks should be saying to themselves, we demand that this be repeated. We demand that this be repeated and resolved. But instead, what happens is censorship. Like, you're not going to publicize this, because what they did was they engaged in an email campaign to all the different editors of all the different science magazines and journals, all of them. Make sure you don't publish this, which is why this guy was left to write a book and make a website. That's it. Like, most flat earthers are not discussing anything about the Book of the Sun, which explains a whole bunch of stuff. So it's left to, well, being put in a book, because I know they're just saying it, wouldn't have it passed around. Anyway, here you are. Am I screen sharing? Yes, I am. Okay, on the left is lithium. On the right is plum. Next to that is iron. Next to that, aluminium, then carbon, then boron, then beryllium. So watch. I'm going to play this several times. I'm not going to put it in slow-mo. It's only a 9-second video, okay? Half of the time of the video is the capsule going up. Then it stops going up and starts dropping at free fall. So it's only half the video that shows these elements here, these cylinders doing anything. Only half the video. That's the free fall half. Here we go. Oh, wait a second. No, it isn't. Oh, okay. Oh, yes, it is. Oh, wait. Let me show again. Oh, okay. No, I got that wrong. Apologies, people. Wait a minute. Let's see how long it is. Stopped. Oh, okay. So, sorry. Apologies. Got it wrong. It's even better. So, it's more than 77 centimeters. It must be 16 seconds, the whole thing. So 8 up and 8 down. Or 9 down. Anyway, here. Okay, watch again. Oh, so look. Stan, on the left is lithium. And on the right is lead. In the center is carbon. Interesting, huh? And if with the gradings, the lines, looks like lithium is falling a little bit slower than, lead is falling a little bit slower than lithium. Now we can see for sure, this is definitely falling slower than lithium. And then it hits the bottom. And let's play it again. So it's approximately 7 seconds drop. No, it isn't. Whatever. Let's count. Let's see when the things start bouncing. 4.5, 5.5. Yeah, 5.5 seconds. 5 seconds, just under. So forget the correction that I made. It's not. When these things bounce is when the thing has hit the ground. The receptacle at the bottom. Okay. So let's watch it again. I'm going to play this over and over. Oh, there you go, rising up. Huh. All of them the same mass. So all of them, let's say that they're 50 grams each. Okay? All of it. Each one is 50 grams. It's the same mass. Play. So how about you repeat this? Nope, not allowed. But that's okay, because after seeing this, I asked somebody who I thought would know for sure if things really do fall at the same rate, because I've always suspected not. That person might be watching this, and he'll know that it was him that I was talking to, and he would vouch because he's an honest person. He would say, yeah, I remember that conversation, unless he actually forgot. The conversation went like this. Are you sure that things really fall at the same rate? Yeah. So if you took 2 eggs that weighed the same, and you emptied one of them, and you dropped them, they would both fall at the same rate. They should. Say, okay, well, let's test that. So I'm going to test that. I wanted to test it with orphan red. I couldn't find anywhere high enough to show anything, really. So, but this is something that I will be testing because I've wanted to for a long time. So anybody in the area of Greater Manchester who wants to test this with me and can figure out somewhere we can go where there's, I have to give a wrench up. Stephen Allenbow, ad moderator. You're speaking out of turn, Stephen Allenbow. That's a thought experiment. He then brings it to Earth, and I showed it in this video. So don't be silly. Anyway, anybody in the Greater Manchester area who can think of a high enough place, so if you live in a tall building and you don't mind dropping eggs out of the window, okay, we can do, well, I'm thinking of 3 tests: boiled egg, non-boiled egg, and hollowed egg. Drop them from a platform so that the platform drops them all at the same time. Not holding where you might drop one half a split second earlier than the other and then see a split second difference. No, a platform, drop. Let's see what happens. Because what might happen is something that goes completely against what we think. Like we might think the egg, the full egg, will fall at the same rate as the boiled egg. So the raw egg at the same rate as the boiled egg. Both of them slightly faster than the empty egg. What if it turns out that it's the other way around? That the other 2 that there's a difference between the boiled and non-boiled because of different conditions, because the electrochemical charge has changed and the environment is an electric environment, and it's the empty one that falls fastest. What if that happens? So I'm going to test it. If you're in the area, please type X. If not, I'm going to have to try and rope in my Globelink friends who keep backing out of things that they've agreed to do, like the tube test. RL Ajito writes, well, if you go higher, the empty egg will get slowed by air. Will it? Why will it? There's some surface area. So why will it? I mean, that does go against the universal free fall, you know. Like it goes against the theory of universal free fall. The weight should have no bearing whatsoever. And if the surface area is the same, then that's also not a factor. Hillgate Tower. I don't know if we can get up to it, dude. If we can, let's do that. Okay, Richard, you're on, but we'll have to find somewhere that's like, I think higher than 50 meters would be good. Mark of Melbourne writes, eggs are pretty ergodynamic. They are indeed. Yes. Yeah, so how about we start doing tests? By the way, somebody sent me a whole bunch of really cool feathers. I'll show you. Just give me a second. How's this for a feather to test the feather versus hammer drop? I have done it, but my camera keeps messing up on me and making everything really dark. Is this a good enough feather? Huh? So I'm waiting to do it, and I want to do it with very spongy carpets so that the feather and the hammer will both bounce pretty nicely. Just for the non sequitur guys, well, the ex non sequitur guys who had a problem with reality. They couldn't accept that a guy in his bedroom dropping a feather and a hammer would exhibit that feather and hammer apparently falling at the same rate. And then somebody would replicate that on like a kitchen with the scales and weigh the hammer and the feather, and in the same shot, drop them. How just, oh my gosh. And I've done it myself, and it's like, oh gosh, good heavens. Anyway, there you go. Rock Lover, drop them off into water versus the ground to see if there's any difference in speed. It's a good to see whether water has a repelling action. You mean that's interesting? I haven't thought of that. Like a repelling action at a distance. I mean, the Divine Plane. How you doing? Oh, dude, you could probably do this. You live in apartments. If you can get to your terrace, and usually in Spain you can get to the terrace, dude, go for it. I'm not saying, you know, litter, but, you know, pursuit of truth. Yeah. But I'm going to do it. And that's just a really simple way of testing. 2 eggs, make sure they weigh the same, then empty one of them. Just put 2 holes, blow through, and then what the best thing to do, I think, would be to fill the hole, well, the 2 holes, with a tiny bit of wax to make sure that the surface goes back to being or maybe some glue, goes back to being universal, like universally smooth, like it was before, like intact, so that if it falls slower, Globalies can't say more resistance because of the hole, I'm acting like a crate. Oh. Yeah, so there you go. Yes, and it will be a scrambled egg party after the experiment. I'm just curious. I want to know. Does a boiled egg fall at the same speed as a non-boiled egg? And is that why birds don't lay eggs whilst flying? No, I know. I was playing with that joke before. have you investigated Sagrada? What? Wait, Familia Gaudi. From Sagrada Familia Gaudi seems to have been a flat earther. Yeah. So Marie, I have not. I'm pretty sure that he was. I've thought this before. The guy wasn't a trained architect, and he built some amazing stuff. He also set up the La Pedrera so that the sunrise would illuminate. The sunset would illuminate in a stratified manner those famous balconies. But no, Marie, if you have anything that I could look at, pass it to me, and I will. Yeah, there you go. I think I'm going to quit. I'm looking through the chat. Everybody seems good. There doesn't seem to be lots of yeah, Richard Archer. I thought you would. Yeah. Okay, so there you go. I hope you enjoyed this. And remember, if you want some comic relief, really watch the series Barry. That's what it's called. Barry. Because it's good. Very funny. Okay, that's it. I'm off. Thanks for your time, guys. And again, go. Oh, what I'll do it right now to save you guys time. Give me a second. Got a knot in my back. I'm going to paste a link to George Smith and Effie Mex, just so you guys can go over and give them a thumbs up just for making the video. Sorry, it's going to take me a bit longer. And if nothing else, please just never to anyone repeat something that you haven't checked yourself. Just don't. And please, like, really, don't look at somebody pouring water onto a bowl and seeing the water drip off and then go and repeat it. It's like, that's stupid. Like, think about it first before you go and do something like that, because it's stupid. So Laurie Gale, greetings, long time. So Laurie Gale's still around, but Pat Steer isn't. Looks like some people have more fortitude than others, because Laurie Gale received some abuse, and accidentally by me. Not accidentally, but I have apologized for it since. Yeah, just that I say that. Globebusters, I don't know if that... yes, okay, so there you go. It is the right one. So I'm giving you a wrench, like everybody else. Yes, so nice to see you, Laurie, just thought I'd say. Hope you're feeling better, Bob. I'm putting differences aside on this, because I don't hold a grudge. And yeah, anyway. So Billy, oh, interesting. Billy Wassa, I won't forget to find the links to Effie Mex and George. Okay, so don't think that I'm getting sidetracked and will forget. Billy Wassa writes, flight times from Lisbon, oh, it scrolled, to South America and North America do not line up with your map. That's fine, Billy Wassa. It's okay, because you don't know the actual flight speeds. You don't. You have no way of checking the flight speeds. You have a way of checking the sailing speeds. So how about you pay attention to sailing speeds instead, you know, and compare my map with the globe, because I've done it and I've done it on this channel. But anyway, you can have a wrench. There. Now, oh, so here's a good point. Billy Wazza, you're saying that the flight times that you believe are based on some standard of velocity that is true, that those standards of velocity, of speed, of flight speed, they're true and correct. There's no disguising, no hiding, and they don't match my map. But you've just seen a video of a scientist exposing a scientific fact and showing that it isn't a fact after all. Do you see? And you've seen how the guys who work at the laboratory where that experiment was done, sent emails to say, do not peer review this, which is what they said. Okay? In technical speech, don't peer review this. It's this other explanation why those things are doing that. And we're not repeating it, and don't repeat it yourselves either, because, you know, our jobs are on the line. So do you really think that the flight speeds and the sailing speeds are going to be the standards that you're told? Just think about the Cutty Sark. I tell you what, instead of wrapping up, I will show this again. Just a second. Oh, I also urge people to go and watch Mr. Chesick, because it's very funny. Right here. Okay. Okay, so in the chat, I'm pasting links to George Smith, who made the video that was then translated by FEMX, and which I then voiced. George Smith passed it to me, said, dude, you've got to do this. You've got to do something with this. And I saw it and I thought, oof, I will. But it's going to take some work. And so luckily, FEMX translated it into English. So I just pretty much just gave it a voiceover and did a little bit of side research into it. Okay, so there's the link to George Smith. Please go and give the guy a thumbs up. It's nice, you know, and it takes no time, and it's nothing, you know, it's nothing to go and say, dude, thanks for that. And he does speak English, by the way. So if you want to write a comment, I'm sure it will be appreciated. And the same for FEMX, who went to the trouble of actually translating it. These Serbian geniuses. Oh, wait a minute, Serbian genius. Where have we heard that before? Wait a second. Isn't Serbia, Romania, Croatia, isn't that the region that destroyed the Roman Empire? It is. That region. Kaput. Isn't that the region that stopped Genghis Khan? It is. Oh, ooh, feisty region. Anyway, so what was I going to do? Yes, I was going to do this. For the person who was saying that the flight times don't agree with my map, it's like, that's okay. I'm not worried. It's really simple. They go slower here and they go faster there. Is there any evidence of this? Well, yes, there is. See, I myself was on a flight. I'll tell you what, I'll pull up Google Earth and I will show you with visuals, okay? Rather than this. And you'll have to take my word for it, or you could go and try and prove that what I'm saying is false and instead prove that what I'm saying is right, okay? It was a flight. I took a flight from Almeria to Manchester. Taken it many times. I have a family in Almeria. They're not from Almeria. They're from Catalonia, but living in Almeria. So, give me a second while I activate Google Earth. Right, so look, let me screen share. And what's happened on this day is those feisty French went and decided to have they decided to have a strike. You know, one of the effective ones, which is we're starting tomorrow and everywhere, the whole thing, until you bow down to us because you're supposed to be working for us, not the other way around. Okay, government. Right, so this is what happened. I was in Almeria here, and we usually fly to Manchester. Okay, that's it. We fly pretty much like this. But instead on this day, France here was on strike. They had air traffic control on strike in support of the baggage handlers. Did you hear that? The air traffic, highly educated middle class, in support of the, well, working class, not highly educated baggage handlers. God, that breaks the rules, doesn't it? So this is France like so, and this, all of this region, you're not allowed to fly over their airspace because, well, air traffic control is saying no. Okay, so you can't. Now you might think if this was a situation, you might fly this way and just, you know, avoid this little area here. See, you just fly, well, this way. Turns out, nope, we flew. Well, let me clear that. So this distance, 1,132 miles, 37 miles, whatever. Clear. Nope. Instead, we went. Oh, sorry, I got the wrong tool. Clear. Get the path. We went over Germany. That's right. We went over Switzerland and over Germany. Can you see this route to Manchester? That's 700 miles longer, give or take. Okay. But it took exactly the same amount of time. Now, here's the weird thing. Because this was happening with the flight didn't actually fly this route. It went first to Barcelona and picked up some passengers there. So let me see if I can do this. I don't know if it's going to work. And here. Oh, okay. I can do it this way. Okay. But this here is first a deceleration of the plane so it can land, and then a takeoff of the plane so it can accelerate to cruising altitude. Okay. So you're hearing that? Flight speeds. Okay. It has to slow down to land, then it has to accelerate to cruising altitude. It took off, landed, took off again, flew round the top of Switzerland and Germany to Manchester in exactly the same time, like literally exactly the same time as when it does this, which is, well, 500 miles less. It's interesting, isn't it? It's almost like they could just go faster. And instead it was like, oh, we picked up good winds and we've made up some time. Like, oh, that's interesting. That's like almost an hour's of flight. It's like 500 miles an hour, you'd agree, is an hour's flight time recovered. Do you get that? That's interesting. But now, never mind that. Clear this. Now we're going to do this instead because I love this. We're going to trace this distance from London, and I'm going to go like this round to Sydney. Okay, that's what I'm going to do. Round to Sydney, and then from Sydney south of New Zealand. And oh, wait. Before this, let me how do I do this? I can just stack all of these here. Okay, just so we see the distances. Okay, globe believers. Okay, and doubters of my map. 2. Okay, so this isn't actually increasing the distance. Okay, I'm just stacking these here so that I don't have to start again. And there. Okay, right. The distance here is 15,000 miles in nautical miles, and I will go back to miles. Okay, but in nautical miles is 13,190 nautical miles a cargo ship did in 77 days. 77 days to do 13,000 nautical miles. So let's go back to miles. And now let's go from here and carry on. Oh, this is going to be a pain. No, it wasn't. Okay, back to round New Zealand, south of New Zealand. This is the Cutty Sark. Okay, this journey is famous because it was the fastest journey ever sailed, fastest trip by any of the 1800 cargo ships, and it went through the Falklands, which is why I've zoomed in like this. And now I can zoom out. Oops. All right. Round and back to London. That's, watch carefully, globe believers, that's 30,588 miles. In nautical miles, that's, well, 26,581 nautical miles in 150 days. The whole round trip. Okay? On your globe, that's absurd on your globe, these distances. But they happen in the real world. So, wait, not the distances, the time. Considering the slowness of cargo ships, sail-powered cargo ships, considering the slowness, that's ridiculously fast. And then, let me clear that. Remember, 26,000 nautical miles. We'll clear that. Now we'll stay at nautical miles and we will do the Antarctica trip, the Antarctica race of Fyodor Kunyakov. Okay, from here, and you can plot it as neatly as you like. I've done this several times already. This is in a racing yacht. 11,000 nautical miles in 102 days. How much did the other one do in 150 days? So 25,000. And you might say, oh wait, but that doesn't count because a wizard did it. No, I joke. It didn't do it really. That doesn't count because he was solo. It's a non-stop race, but it somehow doesn't count because he was solo. It's like, okay, well, let's do this one, which was not solo. From Cape Town, down this way, and round. And I have done this one before too, and you can all do it too, Globelings and map doubters. Below the 60th parallel, crossing over here. Can you see here? It crosses over. Okay, crosses over to Hobart. That's 18,000, is it? 16,000, not 18, sorry, 18,000 nautical miles in also 103 days actually. This is a crude ship. But the Cutty Sark did another 10,000 miles more in only 48 days more. That's not working on your globe. These, the last two that I've plotted, are racing yachts. Think delivery truck versus Formula One. And you might say terrain differences. It doesn't matter. The Cutty Sark sailed along the same region as some of these. Portion of its region from here. Let me clear that. From here across to here. Same region as the Fyodor Kunyakov. Okay, the record holder solo. Same region. Okie dokie. So, if you can't explain this with your globe, which you can't, because when you break down the speeds, they're traveling in a racing yacht at approximately 8 miles an hour versus a Cutty Sark, which is traveling at approximately 15 to 17 miles an hour on your globe, and your globe contradicts the captain's log. where he explains that from this point on, from here on, did 300 miles a day. And you can't do that on this globe. Let me clear that. From this point on, 300 miles a day to London. Okay, it's just, it doesn't fit. It doesn't work on your globe. The speeds of your globe are wrong because the distances of your globe are wrong. And racing yachts are fast yachts. The wind carries them very fast, especially when the wind is very high. When it's very high speed winds, they travel, well, highly fast. They're designed for traveling in very high winds, and very high winds go with very turbulent waters. You know, it's not very high winds and nice gentle waters. It's high winds and choppy waters. The racing yachts are made to go with high winds and choppy water. So you can't say, well, it must have been choppy water, therefore they must have gone slow, because the ships are designed to go fast over choppy water. It just doesn't work, guys. So you need to start checking what you believe. You globe earthers need to check what you believe more than flat earthers. Flat earthers need to check what they're repeating. Okay? Because they're repeating stuff that's wrong. But you guys, nearly everything you repeat is wrong, you globe believers. Like, really, just watch the start of this video and you'll see what I mean. Okay, now I'm going to go and say goodbye to everybody in the chat and bail. Okay. Oh, I see somebody without a wrench. Trade winds, Thailand 192. You can have a wrench too. Trade winds. Yes, and areas. So here's something that Bob brings up. He in the Globebusters thing, he brings up a device called the gravimeter. Did you know that there are regions on the Earth where gravity is lower than other areas, and regions where the gravity is higher than other areas, and that some of these areas are consistent? They have consistently higher or consistently lower. That some areas it fluctuates. In fact, most of the world it fluctuates, but some areas have a mean, a base level that's generally lower, and others a level that's generally higher at sea level. Okay, so the tip of Sri Lanka has a much lower, strangely, much lower gravitational pull. The Indian Ocean, where the doldrums are. Kind of interesting, huh? Anyway, I see two other people without wrenches, and you can have a wrench too. And then I'm bailing. I hope you enjoyed this, guys. Yeah, Helen Degenerate, your name just jumped at me, so I'm saying hi. And everybody else, thank you very much for hanging out. If you haven't watched the start of this, do. And you might not want to share this whole hangout. You're welcome to, of course. But the first part is based on a video which is on my channel, a standalone video, which is only 10 minutes long. So you might want to share that. Okay, guys, that's it. I'm bailing. Thanks for your time. Bye.